Hey guys, this is Mrs. Bolin. Sorry about the technical difficulty today in class. I appreciate you guys being patient with me, but I did want to make sure that I went over these notes with you guys just so that we can spend tomorrow getting ready for the exam. So if we are looking at problems that involve a proportion, we're going to look at this first column first if we're just dealing with one sample. So our population parameter is going to be P, which is the true proportion. Our statistic, we're going to use p hat, which represents the sample proportion. So the mean of our sampling distribution for all of those p hats would be equal to the true population proportion p. The standard deviation of our sampling distribution of all of our p hats there would be the square root of p times 1 minus p over n. Be sure that this square root is over the entire thing, not just the top. And then we also want to make sure that we have met that 10% condition in order to be able to use the standard deviation formula. And that just basically says that our sample size is smaller than 1/10 of our population. We also want to check the large counts condition just to make sure that we can use an approximately normal distribution for our area values there using Staplett. And so we want to make sure that n times p and also n times 1 minus p, that both of those are greater than or equal to 10. If it meets that condition, then we can say that it's represented by an approximately normal distribution. And we don't actually have to do this last step. So this last step would be if we do not have access to that technology, if we can't use Staplett, you would want to find the z-score. We always take the sample statistic, subtract the population parameter, and divide by the standard deviation. We do not need to do that if you're plugging directly into Staplett.com. So that is for if you had one proportion there from one sample. So if we have two samples, looking at two different population proportions there, the parameter that we're considering is the difference between those proportions. So P1 minus P2, be very careful about this little sub 1 and 2. Sometimes they'll use letters to represent two different groups, but make sure you look at the order there that they're being subtracted, because that will change your answer, whether it's going to be a positive or a negative difference. So make sure that you look at the problem and see which one's listed first or second when they're asking for that difference there. Then our statistic is then going to be p hat 1 minus p hat 2. So that's the difference in sample proportions. Or sometimes it might be p1 hat minus p2 hat, I think is technically the correct way to say that. But the mean of the sampling distributions then would be equal to the difference in our population proportions. And then our standard deviation is plugging into this somewhat ominous looking formula, but not too bad if you just pop it into Desmos there. Remember that we're just using the proportion from our first population times 1 minus that proportion divided by the sample size from that first sample. And then we're doing the same thing for the second one, adding them together and then making sure that that square root goes over that whole thing. You also want to make sure that the 10% condition is met for both samples, that they're both less than 10% of the population size, and that the samples are independent. Lastly, we want to check to make sure that we have an approximately normal distribution by making sure that both samples meet the condition for large counts, that n times p is greater than or equal to 10 in each of these areas. And then thankfully, we don't need this doozy of a formula if we're using Staplett. If you did, you just pop in the values that they give you in the problem. But again, if you're using Staplett to find the area under the curve to the left, to the right, between two values, we don't need the z-scores, because the z-scores are just to standardize so that we can utilize table A. So that is it on the population proportions if we are looking at one sample or two samples. Whenever we have those two samples, we again are considering the difference in the proportions. So next we will look at the formulas for mean.